In this video, we will going to take up one more problem on shaft. The problem number 23. It reads as, design a suitable diameter for a circular shaft required to transmit 90 kilowatt at 180 RPM. The shear stress in the shaft is limited to 70 Newton per mm square and maximum torque exceed the mean by 40%. Also, calculate the angle of twist in a length of 2 meters. Take G equals 0.9 into 10 to the power of 5 Newton per mm square. So here he has given to the circular shaft required to transmit 90 kilowatt power. So capital N will be equal to 90 kilowatt and the small n is 180 RPM. The shear stress tau is 70 Newton per mm square and the maximum torque exceeds the mean by 40%. That means T max will be equal to 1.4 into T mean. So small l will be equal to 2 meters, that is 2 into 10 to the power of 3. And we need to calculate the angle of twist and also the diameter. Take G, which is 0.9 into 10 to the power of 5 Newton per mm square. Since he has given power and RPM, so capital N will be equal to 2 pi N into T mean divided by 60,000 kilowatt. Substitute the values of capital N and small n in this equation. So that is 90 will be equal to 2 pi into 180 into T mean divided by 60,000. So T mean will be equal to 4774.65 Newton meter. So that will be equal to 4774.65 into 10 to the power of 3 Newton mm. So what will going to be the maximum torque? The maximum torque T max will be equal to 1.4 into T mean, which will be 1.4 into 4774.65 into 10 to the power of 3, which will be equal to 6684.51 into 10 to the power of 3 Newton mm. So the maximum torque transmitted by the solid shaft T max will be equal to pi d cube by 16 into tau. So d cube will be equal to 16 into T max divided by pi into tau. So T cube will be equal to, substitute the values now, 16 into 6684.51 into 10 to the power of 3 divided by pi into 7t. So d will be equal to, taking the cube root of this equation, which will be equal to 78.64 mm, which is approximated to 80 mm. Now the diameter of this shaft, which d will be equal to 78.64 mm, which is approximated to 80 mm. Now from the torsional equation, we have G into theta by L will be equal to T by JP. So where R will be equal to 80 by 2, which will be 40 mm. So angle of twist will be equal to T into L by G into R. So therefore 70 into 2 into 10 to the power of 3 divided by G into, that is 0.9 into 10 to the power of 5 into 40, which will be 0.0389 radians. So convert this into degrees, 180 into 0.0389 by pi, which will be equal to 2.23 degrees. So this is how you will be able to analyze and solve this particular problem. Thank you.